So it looks like the magnesium ribbon is now completed and all used up and has converted a hydrochloric acid with some hydrogen gas as one of the products in a single replacement reaction in the gas tube. So what remains to me to do is I read this volume at 32 milliliters from the top to here is how much hydrogen gas I have in there. So what I need to do is to loosen this up so I can pull it out of there. I need to pull it up so I can reach my finger in it because I don't want any atmospheric air getting in there. And I will take the clamp off a little bit further, keeping my finger over the top. And then I'm going to stick it into keeping my finger underneath so no air gets in there. And I don't see any bubbles going up. So now the purpose of this column is to equalize this level with this level right here. So I have to, it's going to be close. Ooh, I'm getting close to the end point. I might have to adjust this a little bit. Yeah, I'm losing it a little bit, but right now it's equalized. And I need to take that measurement right there, which is, come back down here again, so I can see it a little bit better when I get the two levels together. That's the level I want. And that's at 30.4 milliliters. Okay, I can drop that off now and write this into my data. So I'm going to come now to my data sheet here, and you can see that I put in red there, the volume is 30.4 when I equalized the pressure to the atmosphere instead of it being 32 as it was in the experiment. I now made that adjustment. So let's go back to the top here. So what we're trying to do here is the combined gas law and figuring out that the molar relationship is when we have P1 V1 over T1 equals P2 V times V2 over T2. Whenever you make a change of things, we're going to try to calculate from this data, if we would have had 1 mole of hydrogen gas, how much would its volume be at standard temperature pressure? Based on the pressure values and temperature values and volume values that we had with this particular experiment. So I mentioned to you already that 1 meter of magnesium ribbon is weighed 1.6 grams. What's highlighted in red is you need to figure out how much 2 centimeters of magnesium ribbon is going to weigh. So that's going to be an important mass value that you convert to the mole. So you know how many moles of magnesium were used in this reaction. The room temperature today is 19 degrees Celsius, and you'll need to convert that to Kelvin because these calculations are based on that. And then our barometric pressure today for this area is 29.8 inches of mercury. That's English system, inches of mercury. You're going to have to convert that to kilopascals. Sometimes it's expressed as millimeters of mercury in a barometric column. We'd also figured out our volume of gas is 30.4 liters. You might have to convert that to liters. You really don't have to do that until the very end of the calculations. And we need to factor in our partial pressure. Our partial pressure, because of the presence of water in that tube, we have to factor that those molecules, there's some of the water molecules are in vapor form, gaseous form that also exert a pressure within the gas tube. So there's a whole chart for that, which is found in the Handbook of Chemistry and Physics, which I pulled out right here in this particular chart. And I went and looked it up for 19 degrees. What is the value? 16.477. but that is expressed in millimeters of mercury. You'll have to convert that to kilopascal, so watch out for that. Coming back here to finish up, you can see then that we have the data necessary to be able to do the final calculations on your data sheet.